we're live, folks. We got Dr. Denver Fowler into his house. We got from North Dakota. Is that right? Dickinson, North Dakota.
Yes, I'm originally from England, but this is Dickinson, North Dakota.
Oh, okay. I didn't know if there was another colony in North Dakota I didn't know about that we formed. And we got Wild Trees, Biologist. Remind everyone to subscribe to this channel. Please subscribe and share. Always to listen, watch, and follow are on BobbyDizzle.com, and it's right here. But we have Dr. Denver Fowler on the podcast today. Dr. Fowler is a curator at Dickinson Museum Center in Dickinson, North Dakota, and founder of Fowler Paleo, former Horner Lab, and correct me on any of this that I get wrong, which is a paleontologist organization dedicated to continuing the field work of Dr. Jack Horner. Most of you may have heard of Dr. Horner as the world-famous paleontologist, also the technical director of the first 5 Jurassic Parks, and the inspiration for Dr. Alan Grant, portrayed by Sam Neill in the 93 Classic. In addition, Dr. Fowler was one of Jack Horner's last PhD students, getting his getting your dissertation in 2016, getting your doctorate in 2016. Thanks for being on, Dr. Fowler, Denver. We were having a crazy discussion about beforehand. Let me ask one immature question before you two talk and I sit back. There's a principle when it comes to how dinosaurs look, how their skin is like saran wrap to the bone. And I can't think of what it's called, but it's like if a goose looked like that, it would be this horrible looking creature with like sticks for arms. And I can't think of it right now.
They call it shrink wrapping.
That's what it is. That's because I said saran wrap, didn't I? Got it right. Is there any effort to make them look more realistic to what they may have looked like, other than what we're doing with the shrink wrap look?
Oh yeah, I mean, there's a lot of people these days. I mean, with the rise of new media, there's an awful lot of artists out there who are trying lots of different reconstructions and different methods and sort of different extremes. So some artists are known for making their dinosaurs look too skinny. And other artists are known for making their dinosaurs look very, very well built, shall we say. So they all fall within what we would say was a spectrum of possibility. So how accurate we can be with that is sort of it's a growing field, I think. Like looking at muscles and things like that is one thing, but then looking at how rounded a dinosaur might have looked is a little bit more difficult. And we started to look at things like mummified dinosaurs and realizing that they might have been a little bit more robust than has been previously reconstructed. But if you've only got a skeleton, I've drawn a few pictures myself. If you got a skeleton, you kind of trace around it, and so your sort of natural inclination as a starting point has a sort of shrink wrap look to it. And as we learn more about where muscles lie over those bones, we get more accurate reconstructions.
Just looking at a chicken and a penguin and knowing that they were dinosaurs at one point, especially a chicken who will eat a frog, rip it to shreds like the goat on Jurassic Park. I'm thinking, did dinosaurs just look like big chicken, with the hackles, the roosters having the hackles? I'm like, that would have been insane, 40-foot hackles. But then you see like the swans if they were shrink wrap, they would just have the sticks for arms.
Yeah, but I mean, you bring up chickens, and we think that the big wattles and the crests and things on chickens, we sort of see past those because we think of them as normal. But it's completely reasonable to think at least some dinosaurs might have had such things. So they always look kind of jarring to me when people draw them on their pieces of art. But it's reasonable. It's a reasonable suggestion, and there is some evidence that some dinosaurs might have had these kinds of soft display structures. Obviously, they don't fossilize very often.
So you think the T-Rex was fluffy, like a little fluffier with the feathers and everything?
I think when it was young, I expect most dinosaurs, at least most carnivorous dinosaurs, theropod dinosaurs, would have been covered in fluff. Whether or not they kept that fluff as they get older, we have, I think, Tyrannus from China has got some evidence of filaments on its body. But then we've got skin impressions from tyrannosaurs in North America, which don't show soft filaments of adult tyrannosaurs from North America.
What part of the body is that impression from?
I don't remember, but usually you're sort of across the back region tends to be fossilized more commonly, and sort of the less interesting places. We'd love it if we could get a nice face
Yeah.
preserved, but
I
you
was
don't
going
get
to
that.
say, because, like the chicken's upper leg where it's still yellow/orange, it has those like scaly attributes to it that would look a lot like you'd think dinosaur skin.
It's interesting, actually. I mean, when you look at silky chickens, they get feathers all the way onto the feet. And so there have been genetic experiments shown where you can basically take a scoot or one of those large scales on the chicken's foot and then switch a gene or something, and it'll turn into a feather. And so that was a quite early experiment done to show that feathers and these scales are actually developmentally interchangeable. So part of one bit of research that we did was looking at the feet of raptors, both birds of prey, modern birds of prey, and also raptor dinosaurs, and how they might use their feet. And an interesting sort of side offshoot of that was looking at the scales on the feet of raptors and how they're different amongst different raptors, and that might be related to the different kinds of prey that they take, and whether that might give us some suggestions in the fossil record. Because when you see things like T-Rex or the drawings that people do of dinosaur feet, of carnivorous dinosaur feet, are usually based on emus. So they have these great big scales on the feet and then up the metatarsus. And that might not be unreasonable, because when we look at modern birds that stride through long grasses and things, they tend to have these large scoots that help protect the feet a little bit. But when you see birds that don't walk through long grasses as much, they often have smaller scales on the feet. If you think about, if you've ever had like a pet parakeet or something, you look at its feet, they're much more small, sort of skin-like. And we looked at birds of prey. So if you look at fish-eating birds of prey like the osprey, they don't have these big scales, really big scales on the feet. So we suggested that was basically because their prey don't fight back. If you catch fish, once you've got it, you've got it. It's not fighting back.
Yeah, that's why eagles have that kind of foot. They have like that fat going down to their foot kind of thing.
Yeah, but that's a question that I don't think I found. I've not had an answer to, is like why some eagles are called booted eagles, why they have feathers going all the way down to the feet and others don't. Whether there's any functional or display aspect to that, I don't know. But it's an interesting pattern.
It is. The reason I asked that question first was like, I've always, you look it up and no one's got a good answer for the shrink wrap thing. And I think what you just said about raptors having their feet look like what they prey on that's probably the best answer I've ever heard, honestly. And if you look at I'll bring it up on here, the upland moa foot that they have, it's got the emu look to it. That old dried up foot. I know you've seen it. The old one from New Zealand.
Yeah, I think I've seen it in the past. I mean, yeah, those big scoots. You look at any ground living birds that walk around a lot, they have those big scoots on the toes and on the metatarsus, and it's less common in tree living birds. But we do see it in birds of prey, where I think they need little bit of armor for the feet to stop their prey from scratching at the toes and stuff.
Yeah, it's like a catcher shin guard right there on their legs.
Exactly.
Yeah. I used to be obsessed with emus back in middle school and high school. Even tried to hatch an egg from a farmer I got. They're incredible. If I ever have any acreage, I'm getting one emu. I don't know what I'm going to name it. I haven't thought about that. I haven't thought that far out yet. But when you're talking about raptors, and I'll just touch on Jack Horner. Why do you think that he let them call the raptors in that movie not Dionysus? Or what's the word? Deinonychus? Yeah, when they were clearly not raptors, because raptors are, big as a turkey.
Well, I think that a lot of those kinds of production decisions are made by the directors and the producers.
I know the answer. I'm just venting. I know the answer. It's bothered me since I was little, because I had a Dionysus, the same size as a toy raptor from Dino Riders. And I saw that I got the raptor from Jurassic Park. I'm like, raptors are like a foot and a half tall. Why they're not a 6 foot turkey like the fat kid said.
I think Velociraptor is a cooler name.
Oh yeah.
I mean, Deinonychus is like, Deinonychus means a more interesting thing, but I think Velociraptor, it's got a V in it. Anything with a V in it is good.
So you don't think Sam Neill holding the little, you bred Dionysus? he starts trying to choke it like he was going to.
Uh,
Just wouldn't float off the tongue well. You bred Dionysus.
Confession is I think I've seen Jurassic Park maybe once.
Oh
I
gosh,
think I saw Jurassic Park 3 once. I have not seen Jurassic Park 2. Maybe it's the
that's
way
too many
around.
times for part 3. By the way, you can subtract 1 from part 3. You'll be fine. It's basically Fargo with the pterosaurs. All it is, same movie.
And Fargo's in Minnesota.
Yeah.
That's
I'm just saying,
joking.
it's got William H. Macy in it for some damn reason. Like, who's casting William H. Macy in Jurassic Park? Like, was Tim Curry busy? What was Brendan Fraser doing?
Oh, I don't know. I mean, I saw I think I saw the new one at the cinema when we were in the field once. But other than that, I haven't seen it. I was a little bit old, I think, for the Jurassic Park films. And I know they're very popular amongst many of my contemporaries because they're all sort of, I think I was like 17 or something, was I? 16. A little bit too old to get into it.
I was going into the 5th grade when part 1 came out, so I was obsessed. But I was also sitting there like breaking it down like we are right here as like a 10-year-old. Like, that's clearly not what that is. And that's right about the time the Utah Raptor came out, like that same summer.
And it's still coming out.
Yeah.
I mean, the big Utah Raptor block, they post photographs of it. It's being a huge block which has got multiple individuals of Utah Raptor in a whole family from down in Utah. Jim Kirkland and his team are posting photographs. It's an incredible looking thing. I'm excited to see what they get out of it. Because, I mean, that animal really is probably one of the most famous dinosaurs. We've all been waiting to see what it really looks like for many years, and hopefully they're finally going to get there.
Isn't it just doesn't it look a lot like what we think the Velociraptor looked like? It was just a lot bigger.
Well, we don't know. I don't think there's much skull has ever been described. And most of what's been described comes from different individuals. There are only scraps, but they have more complete material now, and they're cleaning it up day by day. And they have a family, or at least a group, of individuals of different sizes. So the amount of information, new information on Utah Raptor that's going to come out of that block will be revolutionary for the animal. I mean, with it being so big and so robust compared to things like Velociraptor, I expect it might look a bit different in different ways, but we'll see.
I know that was the big talk that summer when it came out. It was like the exact same year as Jurassic Park, and I know a lot of the magazines I would read, like, well, they really modeled it after the Utah Raptor. I'm like, well, it just came out after the production was over, so it can't be totally accurate.
Yeah, I think they got a bit lucky with that. I mean, one thing is that always kind of jars me when I see the films is they make the heads so wide and so robust and big and heavy set. And raptors have lightly built heads. They're not like T-Rex. T-Rex is a bruiser. It's a big, robust head, very heavily built. Raptors generally not. They're very lightly built heads. Overall their body is very different anyway. But I always look at the heads and they're too wide. But
the skulls you see the skulls are really narrow. Like, you could almost fit them, maybe an exaggeration, like in a Pringles can.
Yeah, if a Velociraptor you could. I mean, there's a little bit of compression, when these things have been buried in rock for millions of years. They get a little bit squashed because they're usually preserved on the side, so they get a little bit compressed, but not well. They get compressed, but you can correct for that.
Let me check. I was looking for a picture here. I was trying to pull up a visual aid of one of the Museum of the Rockies, the raptors they had there.
Oh, those ones are Deinonychus. I think they put that mountain just before I got there.
Have you seen this one? I can't get enough of this one.
It's sort of got a sort of poison white snake kind of Guns N' Roses pre-1991 look to it.
I called it the Joe Dirtosaurus.
Well, we had a nice raptor model made for our museum. Find a picture of that, or if you looked up a Cararaptor at Dickinson. So
the Dickinson Museum.
yeah, there's an artist in Serbia called Boban Filipovic who specializes in making feathered dinosaur. Well, actually, he makes all kinds of brilliant models, but he made some really nice feathered dinosaur models for our museum. He made a Caroraptor, which is basically a Deinonychus-sized dromaeosaurid from the Hell Creek Formation of Montana and North Dakota. And he also made a little alvarezsaurid called Triracuncus, which we named in 2020. And so he made a couple of really nice feathered models for our museum. And I think that they really stepped up a level. Like everybody else has to raise their game for feathered dinosaur models with Boban's work, because he really hit it out of the park with those. He won an international award for one of them.
Really?
And rightfully so.
So what are the species that were native to North Dakota? Only thing I know about, I guess they got to be close to what's in Montana.
Yeah, well, it's an interesting question. In North Dakota, we only have dinosaur-bearing rocks, the Hell Creek age. We have the Hell Creek Formation here. So before that time, North Dakota was covered in the Western Interior Seaway. So we don't have. I mean, there's a chance that dinosaurs might float out to sea and be buried there, but I don't think anyone found any yet. So mostly we're just dealing with Hell Creek. So we have T-Rex.
It's all bottom of the sea stuff here.
Yeah, we have T-Rex. We have Edmontosaurus. With some bone beds of those. Triceratops, of course. There should be some Triracuncus remains. We should have Dakota Raptor, of course, if that's real, which I rather doubt. I suspect it's probably just some large bones and a few other things from an Acaroraptor. We have Anzu, the Oviraptorid, typical Hell Creek species, basically. Although another thing about North Dakota is we do have dinosaur-bearing rocks, but we don't have anywhere near the amount of rock that a place like Montana has.
Yeah,
we have a little bit just south of Bismarck, and then a little corner near Bowman. So richness-wise, it's very good. It's just there isn't very much rock to look in.
that is crazy. I guess I didn't think about the ocean running that far to the west. No, Montana is just basically horses and dinosaurs.
Yeah, when the Western Interior Seaway was at its highest, it went all the way up to the foothills of the Rockies. It was all the way over to the western side of Montana. So it would go back and forth as the sea level went up and down. So North Dakota was always covered. And then some of the areas that we work now in northern Montana, sometimes they were covered by the sea and sometimes they weren't. So we get some dinosaurs, then we get ammonites, we get more dinosaurs, depending on where you are.
It seems like America's got a lot more Cretaceous than anything else. Is there any from the previous eras or periods, or is just the last ones?
Well, and the US has a lot of different age rocks, of course. I mean, it's an entire continent, so it's got a bit of everything. One of the reasons why the Cretaceous rocks are very abundant is because they're on top in the western United States. I'm going to cough. This is the most well I've been for a week.
Oh yeah, I forgot you were sick. I meant to ask you how you were feeling.
Cold. Not too bad if I don't have to do too much talking, but we'll see. So because the mountains were being uplifted, the Rockies, then there was a basin forming behind those mountains, which was where a lot of sediment could build up. So while the Rockies have been forming, and the Proto-Rockies, if you like, sort of the late Jurassic all the way through to modern day, there's a good record of rocks and the fossils contained in those rocks. So, and also because they're relatively recent, they're near the surface. So all those little parts conspire to mean that Cretaceous rocks are very abundant in the sort of western states.
Okay, I'm sitting here thinking, the Rockies are only less than 70 million years old, so I guess they would be the ones that were getting all the Cretaceous stuff as they were coming up.
Yeah, there've been a couple of different mountain forming events that have formed what we call the Rockies today. over the last sort of 100 million years. But the big uplifts, sort of 80 million years and onwards.
Yeah. And the people out west always give us a hard time over here because of the Smokies being so low. Michael, the Smokies are 5 times older. Smokies are older than sharks and trees.
Yeah. I had one night in the Great Smoky Mountains. I think when we were traveling to New Mexico once, it was it's delightful down there. I have to say, when you're driving through the states and it's really, really hot and it's a little bit cooler up there, it was really pleasant.
Yeah, one October we were having a heat wave. It was 95 degrees, and we went up to the top of the highest point in the Smokies, and it was 50, and it was glorious. I'm moving up here until further notice. I can't go back down there. It was like a cat getting put in a bathtub. I can't do it. I'm not getting back in that car and go back down this mountain. And I think over there it was all over here we were all underwater. Like I used to get I had a little archaeologist kit growing up with a brush and a chisels and a little pickaxe, and I'd go up in the mountains and find the limestone that had the layers in it and kind of just wedge those open. I would find all the trilobites, all the little coral, find coral all the time. No,
it's great, isn't it? I mean, I think it's a wonderful thing for kids and, well, for everybody to get into. How I got into paleontology was collecting fossils, and it's like a treasure hunt. But there's a great story behind the things you find, and you never quite know what you're going to get. And all these different kinds of animals from different time periods. I think it's a really engaging way that we can get sort of science and things across to the public.
Oh yeah, it's real and it's right there. Wild Trees, you have anything to add down there? Seeing you're taking it in.
Yeah, man. I got I'm gonna ask three questions, but you don't have to answer all of them. You might forget them. I just want to get them in right now. The first question is, I think it'd be great if you could tell the audience what the broad definition of dinosaurs and how that's different than a prehistoric reptile. Because I always ask people, what's their favorite dinosaur? They're like mosasaur or pterodactyl. And then I'm like, should I tell them? Should I get into this long conversation explaining? And I'm like, okay. And my second question was going to be, my favorite dinosaur is Coelophysis. And I was wondering, I read that, I don't know if you know, but if you could tell us more, but I read that at one point, like hundreds of fossils were found together of these dinosaurs. And I wondered if you could talk more about that, if you know anything about that discovery. And then the third question is about basically dinosaurs in Mexico. I was reading watching a report on the news that there haven't been that many dinosaurs discovered in Mexico. So I was wondering, if you were going to look for dinosaurs in Mexico, what parts would you look at? Those are my 3 questions.
Okay, well, definition of a dinosaur, there are some technical definitions, I'm sure. These days we tend to define them using family trees, cladograms. So we basically look at a family tree, we pick a particular branch, and we say everything within that branch is called a dinosaur. So in terms of what that's restricted to, primitive dinosaurs walked on 2 feet. They didn't walk on all 4s. That was something they did later. And they have legs that go directly underneath the hips. They have this kind of upright leg, which helps them support their weight better and gives them certain advantages. So you brought up Coelophysis. I'll talk about that in a minute. That's one of, it's not super primitive. It's from like the late Triassic. There were dinosaurs before that, but they look very similar to Coelophysis. They're quite slender. They're not particularly big. They didn't dominate their environment for a few million years until after that. And so things like mammoths and and people often confuse, like they think the word dinosaur is basically anything that's big that's now extinct. Mm-hmm. So obviously things like mammoths are like big elephants, and people don't get too confused with that. But when they're reptiles, things like mosasaurs, these huge, basically sea lizards that lived in the sea, or plesiosaurs, these ones with great big long necks, they're reptiles, but they're not dinosaurs, just like a lizard isn't a dinosaur. And a turtle isn't a dinosaur, basically. The mosasaurs belong to a different group. They're variably related, but they're not dinosaurs. Coelophysis.
Dimetrodons.
Dimetrodon?
Yeah, how they're like mammals. Like, how the hell is that even? How does that even work? How are they mammalian?
I find Dimetrodon really interesting, actually. Yeah, I think that whole, we were confused for so long calling them mammal-like reptiles. They're actually reptile-like mammals, if you want. And it really just shows that when we have the basic split between mammals and reptiles, which occurs in the probably in the late Carboniferous period, and then basically these two different, fundamentally different groups just march on and become different progressively over time. True mammals don't emerge until the Triassic period, but all these weird things on the way, like Dimetrodon and Edaphosaurus and all these other wild-looking animals, people didn't really know what to compare them to, so they got called another group of reptiles. I find Dimetrodon really interesting because it's one of the first really big terrestrial carnivores, and I think that brought with it some interesting adaptations and challenges. One, to being big, and two, eating big things. And Dimetrodon's one of the first animals that really addresses this on land. I think most of the carnivores before that were mostly these amphibians that could at least support themselves a little bit in the water.
That was one of the, when I was at the Museum of the Rockies, I had a conversation with, I think it was Stephen Phillips was his name. He worked back there in the boat. He was cleaning off a bone and he walked out and we started talking to him. God, I wish I could remember. I was almost going to get him on here, but I think they kind of ghosted me when they realized I was just some kid hanging out in his mom's basement. But he was the first one I heard about the mammal thing. I was like, really? I said, how new is that? Because I haven't really researched them at that level for about a decade.
It's not particularly new. It's more, I think it's more that the way that it's presented to the public has been changed, and we've just refused to use the phrase mammal-like reptiles, and that's really helped. I mean, that calls them a reptile, but they're not.
Yeah.
They're a synapsid. So that has really helped reframe it, I think, in the minds of the public. I think the coelophysis question, I've done a lot of work in New Mexico, or at least in the past I did, with Bob Sullivan at the State Museum of Pennsylvania. He's retired now. He now lives in New Mexico and lives it up all the time down there. But I went out and collected in New Mexico a bit, so I visited Ghost Ranch. So coelophysis is this small theropod dinosaur from New Mexico. Maybe it gets up to about 2 meters long, something like that. And it's famous because when it's been discovered in a number of bone beds of hundreds of individuals, possibly more than that, of different sizes, in a place called Ghost Ranch, which is I think it's a Presbyterian retreat now, but they've maintained the museum and everything there. And so they excavate these huge blocks that have dozens of coelophysis individuals preserved, and beautifully preserved, articulated. Some of them have gut remains. They have beautiful skulls. Fabulous. You can see them in museums all across America because there were so many of these blocks removed. And they're a great data set so that we can learn a lot more about coelophysis. And that's lucky because it's quite an early theropod. And so we can find out a lot about what early theropods were like because we've got a great data set. It kind of sucks if you've only got dino birds are like this. By the time we have a good sample of dino birds, we're in the early Cretaceous or the late Cretaceous, they've already evolved. So we're kind of trying to piece together their history from a descendant. Whereas with coelophysis, you've got an animal that's, to all other intents, quite primitive, but we have a great sample size for it. So it's a really cool animal that I don't think has been given enough justice. There's a friend of mine, Danny Barter, who just got his PhD from the American Museum in New York, and he was working a lot on coelophysis. I think because it was abandoned for so long. Not really abandoned, but it hadn't been done justice with some of the modern methods, so he's been looking at it again. So I think it's a really cool dinosaur. Now I'm trying to remember what the last question was.
I was looking. I thought that might have been the dinosaur from that Camp Cretaceous show.
Question was about
You can go ahead. Sorry.
maybe in the later season and seen the last seasons. The last question was about well, I have a follow-up question to Coelophysis, and then I'll ask the last question that I had. The second question is, what's going on with those hundreds of bones? Did they die in an accident together, or were there roving hordes of Coelophysis in the thought? Why are there so many bones found together?
Yeah, so the question I think is, why were there so many Coelophysis preserved in these beds? Because it broke up a little bit there. But then that's an interesting question as well. So when you find lots of individuals together in one place, what does that really mean? We really like it when we find that as paleontologists because it gives us a great sample size. But did they all die together at the same time? Or is it what we call a predator trap? So was every year a couple of them fell into a hole and eventually over time it built up? I think there's always been that question with Coelophysis quarry. We know, for example, that it's not just one layer that's yielding hundreds of skeletons. There are at least, I think, 3, and I'm not an expert on Coelophysis by any stretch of the imagination, but I know there's more than one layer, which also has like mass death assemblage. So separating those is important, but they seem to be a mass die-off for some reason. Maybe they were the last individuals living in an area at a drying out lake, that kind of thing. So they go to the lake and there's no water left, so they all just die in the same place. Or maybe it was a huge herd that were crossing a swollen river and they all got caught up in the river and were washed downstream and dumped on a riverbank together. I don't know that much about what's called the taphonomy of Coelophysis, but I do know that the accumulations of Coelophysis have occurred a number of times. So there's something about that environment that predisposes it to being preserved in that way, which is great for us. It's important to understand how those accumulations form, because when you think about it, sometimes you can get a bias towards certain animals surviving catastrophe. Like if you're crossing a river, the really weak individuals might get more easily carried away. So the really big adults might be able to cross the river successfully, but the smaller ones or the weak old ones might get washed away. So you can get a bias in the animals that are preserved. And there are all kinds of other biases as well. Big, heavy animals can sink into mud, so because their feet will sink into the mud, so you can get biases in that way as well. So you have to kind of know by looking at the sediments surrounding the bones what sort of environment they're in and how that might affect the preservation and how that might affect the data that you get on the population from that. So it's a case-by-case basis, because a swamp can be different from a river, can be different from a desert, depending on what the condition is that they're preserved in.
I'm educating myself on Coelophysis as you talk.
Okay, that makes sense.
I like Coelophysis.
Yeah.
I think
it's my favorite dinosaur.
So, all right. What was the last question?
He seems to be. He's got a little.
So my last question was about Mexico.
Oh, right. Yeah. So Mexico. There are a bunch of dinosaurs from Mexico. It's not as thoroughly searched as parts of the United States. But I think I went to Mexico to help out with some dinosaur projects a year ago with some friends down there. And so I helped just identify a few pieces and put some bits together. But they have some really cool new stuff. The challenge is, one challenge certainly is getting them out of the ground. The rocks, at least in this part of Coahuila, which is one of the northern states, I don't remember what they're called. Are they states in Mexico? Anyway, in Coahuila, it's very, very hard, the rock is. So even if you find something, getting out of the ground is a bit more of an effort than perhaps it would be for us in Montana in most places. And also because the rock is so hard, it doesn't weather as fast, and so little bits of bone that do make it to the surface break up. So it's not quite as easy to see things, to find new things, but they are there, and there are people out looking and finding some important stuff. So as with anything, you need money to buy equipment, and you need manpower to go and dig holes, and then you need people working in laboratories cleaning these things up. And the level of infrastructural support for paleontology in Mexico is not the same as it is in the United States. But I know that many of the people down there are really trying hard, and every new find they make generates new interest. And of course, everyone's crazy about dinosaurs down there, just as they are in the United States.
Mm-hmm.
So it's growing. It's just it hasn't grown to the extent that it has in the United States yet. But we're working on a new specimen in Colula, and I know they have a bunch of other things too, which they're working on describing. So there's cool from that.
I just got kind of a mental image of the cartel with the little paleontology wing. Like just watching our archaeologists with AKs, like finding like the femurs of like a brontosaurus. I'm just in my mind, just like, what is that? And like, dig it up. Down in Mexico, when you said that.
Well, it's
be some down there.
Oh, there's some nice stuff down there. It was quite we went down there almost exactly a year ago. It was like spring break last year, and so it was quite nice and warmer. And it was definitely very different from being in North Dakota in sort of March. I'd never been to Mexico before, so it was a real eye opener for me. And I've been to Mexico, New Mexico, but I know that it's a different country, but like the landscape is more similar than North Dakota.
Yeah, the landscape doesn't stop at the border,
I'll tell you one thing. It makes a difference in New Mexico, but it definitely makes a difference in Mexico. When you find something, you have to sit down and dig it up. But there's nowhere to sit in Mexico because everything on the ground wants to stick a spike into you. And like this thorny this and cactus that, and like these weird things that are like razor wire. Like finding a spot where you can just sit down is more difficult than you'd imagine. I've sat on enough cacti when I'm digging up dinosaur bones to not want to have to do that again. And you literally do spend a while pulling all the spikes out of your behind. I sat on the same cactus twice once, and it really annoyed me. But yeah, that one got booted across the field. But it's like, oh, fool me twice,
You look like the hyenas on Lion King coming out of that cactus.
Yeah, at least in Mexico, the spiky plants are quite big, and you can see them a lot more easily. But it really is like you find something nice, but then you can't lie down to it. You got to kind of scrunch up in a little ball to find the one spot that you can actually fit in. It sounds silly, but that sort of thing can really make it difficult. Yeah. It's just another challenge.
Does that initial site survey of an area, does it occur like you see on the documentaries where you got like the guy in the fedora walking through the desert with the pickaxe and he sees something, he just kind of chips at it, pops at it, see if it's worth looking at? Or is it more of a detailed oriented kind of discovery?
It's detail oriented. I mean, we work on public lands in Montana and North Dakota. So we get permits from the Bureau of Land Management. So we're required to take all the information and things. But yeah, you hike around the Badlands basically, and you look for. We cover almost every bit of rock in the areas that we work. You look for little bits of bone on the ground, or just, honestly, I say we look for little bits of bone. That's kind of level 1. Level 2, like the top guys I know in England, like they don't even really look for bone anymore. They look for rocks that are breaking in a weird way. They don't look the right shape to be the local rock.
Yeah, that's kind of what I was asking. How do you know where to start your survey, start digging?
Well, you look for little bits of bone, or you look for clues about fossils, and sometimes that can be, that rock looks weird. If that was just rock, it wouldn't break that way. So there's something about it that makes it break weirdly. And you go over and you take a look, and it turns out there's a bone in there that's making it into a big lump. And so then you've got to assess, is it just one piece of bone? Is it going to be a whole skeleton? So you try and find out where it's coming out. You maybe dig around it a little bit and see if there's more going in. And a lot of being successful in the field, like, you know, the Western United States, there's a lot of dinosaurs around on the surface. But assessing whether or not it's going to lead to something, whether it's worth your time, is a big part of having a successful field program, and that really takes experience. But you know, we do wear wide brim hats to keep the sun out. I think it's an absolute necessity, and we walk about with picks and things.
I don't see how you can go without that. As hot as it gets out there, that sun.
Absolutely.
We had a question from the audience from Mindy, who is our science and biology technical advisor. She's our Jack Horner, by the way.
Okay.
Not nearly as hairy. And she made this shirt, by the way. Thanks, Mindy. Hang on, take it out. Mindy made this shirt. It's kind of itchy, but I'm wearing it. She wants to know if with the Great Salt Lake in Utah expected to dry up in 5 years. Didn't know that. Didn't know that was drying up. Do you expect to find any dinosaur fossils there? Is it good ground to look for fossils?
Well, certainly Utah is an amazing place to look for fossils for a number of reasons. One, the right rocks are exposed on the surface, so there's loads of fossiliferous rocks of all sorts of different ages, but especially dinosaur age rocks. And also, one of the reasons why there's great dinosaurs from Utah is there's a lot of public land there, and so the museums there can go out and look. And those fossils are in museums all across Utah. Some really great stuff. The Salt Lake itself, I'm not sure what the bedrock is under Salt Lake. And I imagine there's probably an awful lot of salt built up there, and sediments, like lake sediments at the bottom of the lake. I wouldn't be surprised if there's like 1,000 feet or something like that. It would be quite typical for a big mountain into mountain lake like that. Salt Lake's quite unusual in the way that it formed, I believe. I'm not an expert on Salt Lake by any stretch of the imagination, but I don't think it's going to be great for fossils, simply because most of the fossils that I'm aware of in Utah are more sort of they're not in that kind of lake basin. They're sort of up in the cliff areas or in Badlands areas, and the lake itself is like a big dish full of salt and sand and mud.
The good news is, if there's not fossils there, the campsites are going to have some hella steaks, because all you got to do is drag them on the ground, slap them down on the grill. I didn't know that Salt Lake formed just 11,000 years ago. That's incredible. I thought it was a lot older than that. I guess that's Ice Age, so that's not shocking. Just a big deposit.
Yeah.
It'd be kind of cool if maybe this is kind of woo-woo, but if maybe like a fossil, like a perfectly preserved specimen, not just dinosaurs, maybe Ice Age fauna, got hung in the glacier and then was preserved like a piece of country ham in the bottom of Salt Lake, and you get it, and it's like this perfectly preserved piece of meat. That's off the top of my head. That's the only thing I can think about.
Yeah, it'd be more pickled, I suppose, with all the salt.
It'd be like corned beef mammoth.
Yeah.
Wild Trees, are you back? I see you came on via phone now. Having a little trouble over there.
Yeah, I thought my old laptop could handle it since I wasn't taking all the load, but I guess not. Still can't handle it.
Of course, man, just shoot it and put it away. Put it out of its misery.
Yeah, no, I'll use it just for typing up stuff. I should use my $3,500 laptop, I guess, next time.
I felt bad. I was like, his new laptop sucks all of a sudden.
No, I thought, I was experimenting. Well, I have another question. First of all, is it correct that the thinking is that the only dinosaurs that survived were the theropod dinosaurs who became birds? Is that correct?
Well, I guess you mean at the KT extinction.
Yes,
they were already birds at that point. Birds evolved. The first birds is about 150 million years ago, give or take. But once you in the late Jurassic, but once you get into the Cretaceous period, we've got true birds, like really quite derived forms. Well, maybe not really advanced or anything, but but they're more advanced than, say, Archaeopteryx, and those are the ones that survive through the KT boundary. What's interesting for me is the question as to why primitive birds go extinct at all. We often think of the KT boundary as being about winners and losers. That mammals survive, they're a winner. That birds survive, they're winners. The dinosaurs go extinct, or non-bird dinosaurs go extinct, so they lost. But when you actually look at the numbers, it's something like 75% of all bird species go into the KT boundary. And it's similar for lizards, and it's similar for mammals. It's just that the primitive birds go completely extinct. What called enantiornithines and things like that. And it's these more advanced, or more advanced is the wrong word to use here, but related to the modern groups, they make it through. And we looked at this a number of years ago now. I still have to write it up, but about why is that? Is there some kind of Stephen Jay Gould once called it group selection, that there's some reason why entire groups go extinct. Maybe there's something about their ecology or their adaptations that makes them susceptible to extinction, whereas a closely related group, but a different group, survive. So we were looking at that as birds. Why did birds survive? These derived birds survive the KT boundary extinction, and that 75%. That 75% overall extinction rate for most groups through the boundary is quite telling, I think. Everybody takes a hit. It's just some groups take 100%. Whatever they were doing, they were really susceptible, whereas everybody takes 75. So I sort of, the way that we envisaged this was, if you take, you might like this, if you take a bunch of targets and put them in a field, and then you just fire a field of bullets at it, and you're randomly hitting all these targets. If you've got 100 targets and you've got 75 bullets, let's say each one, some of them go in twice and some of them go in just once, but you might take out sort of 50 targets with a random extinction pattern. So everybody's going to get 50% on average hit. Sometimes they'll get hit twice, but if you take out 75. Let's say you take out 75% of them, everyone's going to get a hit. So what is it about the animals that go completely extinct that make them go completely extinct? So we suggested that one thing that's shared by these primitive birds and dinosaurs is that they have very long growth periods, or at least longer than others. When you look at a modern environment, I call it adults only. That things like deer, they grow adult size in about a year. When you look at little baby birds outside, they're being fed by their parents. They grow very quickly, don't they? They come out of the nest, they get fed by their parents for a week or two, and then they're basically adult size. And there's a few different aspects of that. One is that they grow very fast, but two is that it's the parents feeding them this whole time. So it's the parent gathering the food to feed the baby until the baby is the same size as the parent. If you're a bird, they're gathering the food. If it's the mammals, well, then it's the mother generating milk made from the food. But you basically mean that every species is occupying a very narrow ecospace, a very narrow niche. When you look at dinosaurs, dinosaurs hatched from eggs, and eggs can't be any bigger than a football, because of the way the gas needs to go through the shell, so the embryo inside the shell doesn't suffocate. So they can never be bigger than a football. Any bigger than that, the embryo inside dies. So even the very biggest dinosaurs hatch from these relatively small eggs. So they have a lot of growing to do. And they did grow fast, but they had so much growing. It took them years and years, which means most dinosaurs have very long growth periods, or relatively long compared to mammals and birds, which is the matter of weeks or a year. Dinosaurs, it's multiple years. That means baby dinosaurs, let's say they're 1 meter long, but the adults are 10 meters long. Well, the 1 meter long animal lives in a different niche, different ecological niche than the 10 meter one. So they form these niche chains. So a baby occupies the small growth size, a medium-sized one occupies the medium size, and the big one occupies the big size niches. And how that affects things at the extinction is, if you take out randomly 3/4 of all the niches, well, if you take out the middle-sized bird niche, oh, that's all right if you're the big bird or the small bird because your niche hasn't gone. But if you take out the middle-sized dinosaur niche, well, then that baby can't become medium. And that medium-sized one is gone and it can't become an adult. So you break the chain. And so these long growth periods for dinosaurs basically make them unusually susceptible to these kinds of unpredictable events like meteorite impacts.
Really? So that's like a little dinosaur is like 3 different animals in one. It's like a scavenger, and it's like a hunting for like a possum, for lack of a better term. And then, wow, I didn't think about that. They're always 3 or 4 animals in one.
The example I like to use is modern day cyprine hawks. So the small one is called the sharp-shinned hawk, and then the medium-sized one is the Cooper's hawk, and then the really big one is the goshawk. These 3 different species occupy different niches, but they're basically the same animal. It's just they're different body sizes. If they were in the Mesozoic, being a dinosaur, the small one, the medium-sized one, and the big one would all be the same species. They'd just be different growth stages. So if you knock out the goshawk niche, as often happens if you do deforestation and stuff like that, well, you know, the Cooper's hawk and the sharp-shinned hawk are still around, and if that niche comes back later, they can evolve into it. But if you're a dinosaur and you knock out that big niche, well, then no one can be an adult. So the whole chain collapses. So we still have some work to do on this, but it basically looks at these growth chains as making these animals extra susceptible. And to go back to your question, I think it was your question, or maybe it was something I made up, but these primitive birds that don't make it through the KT boundary, one thing that sets them apart from the derived birds that do survive is that the primitive ones, they grow more slowly. I think they took 2 to 3 years to become adults, which is pretty weird when you think about it. A bird usually grows really rapidly, but these primitive ones, they hatch, and then they spend 2 or 3 years becoming an adult. And that means that they have a niche chain.
That is a long time for a bird.
Yeah, well, that was the primitive condition. That's how dinosaurs did it.
Chickens are ready to rock in 6 weeks.
It's a really good system if you live in a stable environment, because it means any given species can consume more of the available calories or energy in a system. So if you don't eat the same food as your babies, then you're not competing with them for the same resources. So if it's a nice stable environment where everything's reliable, spreading out your growth through different niches actually acts as a benefit. But in an unpredictable system, in a dynamic system, it's not a benefit.
Yeah, Mindy basically asked the question you just answered. So I didn't want to interrupt while you're explaining it, but yeah, she was the largest birds were the one to go more. I guess it's the more primitive birds that did it with the slower maturation period.
Body size is always something that, I mean, it's not that there's only one thing that affects extinction at the KT boundary, and our model doesn't really say why certain niches disappear. But large body size, it means you can move around more, so you might become less susceptible to extinction. But large animals need more calories. They need a certain size population, which might not be possible to sustain. So they do present themselves as being more susceptible to extinction in general. So it's something that's often put forward that these large animals are more likely to go extinct, and it does match what we see, but it can be for more complicated reasons.
Were there other things besides that KT boundary with the asteroid that caused the mass extinction of the all-star dinosaurs that we know and love?
Well, it was suggested that there might have been the Deccan traps, a large volcanic outpouring of basaltic lava in India.
Lava will do it.
That was suggested that could also be a cause of the KT boundary extinction, and it did occur around about the same time. I know a few years ago there were some experts that came over to the Hell Creek with us in Montana, and they were sampling through the Hell Creek to look for chemical evidence of the basaltic outpouring, because the timing of those outpourings is what's key. Did they occur right at the KT boundary when things go extinct? The current thinking, I believe, is that they started a little before the boundary and they continued after the boundary, but they weren't as active at the boundary itself. So we don't think that the outpourings of basalt were a major part of the KT boundary extinction. They may be contributing towards the decline, if you like, of certain animals towards the boundary. Although I don't actually believe there was much of a decline. There were changes, but I don't think that it was a decline.
Well, I remember the meteor theory / hypothesis popped up when I was just a little kid. Before that, I can't remember what they thought it was. I remember it just died off. That's the only thing anybody ever said.
Yeah, it's a bit before my time. I mean, the meteorite hypothesis came in, I think, 81, but it was definitely early 80s.
Yeah, I was born in 83, so I remember growing up. That never was. I guess it was still in the peer review stage before about the time I hit came online about 1989, 1990. That's when it started getting popular.
Yeah, I think. They found the iridium layer in the early 80s, and then I don't know when they identified the crater in Mexico as being a likely candidate. But as they started piecing together these pieces of information, it was obviously a great, exciting finding in the early 80s. People were chasing this idea and looking for new evidence, so it really took off through that time. But, I was born in 77, so for me it was always there. But some of the older books would say, was it disease? Was it this? And the mammals eat all the eggs.
Because I had those dinosaur books, and one would say they didn't know, and then my newer ones I get for Christmas would say meteor crater.
Yeah, I like the meteorite impact hypothesis. I think it has the most supporting evidence. But you should always look at alternatives. Like one thing I think a lot of my colleagues, a lot of paleontologists get stuck in this. They get stuck in a trap of only believing one idea at a time, or only entertaining one idea at a time. And we're supposed to use what's called multiple working hypotheses. So as a geologist, we look at historical science. So everything we're looking at has already happened. So we can't run a test again like a chemist might. So there's multiple ways to explain what we see. And usually you have a favored way, which is better supported by the evidence. So I might say, well, I 90% believe the meteorite impact hypothesis. I think that it's very well supported, but I'm about 10% on the volcano hypothesis, because there's some evidence to support too. So, and some of the gradual things too. So I'm okay assigning a sort of percentage confidence value in particular hypotheses. Like it's not all or nothing. And you have to do that when you're working with historical data.
It's acceptable. I think it's almost like acceptable to have different views and or toe a hard line in the scientific field with something that can be proven, like the meteor, that it's actually happened. What'll frustrate you is you're dealing with paranormal people and they think something's set in stone when there's zero evidence of anything. The paranormal experts, like, what the hell are you talking about?
Well, I think the nature of science is that things have to be testable.
Yeah.
And they have to be repeatable. And so that's basically what we deal with in science. Like, people believe a lot of things. And I used the word believe a little bit earlier, and scientists don't really believe anything, I don't think. We have things that are testable. And to test something, it doesn't necessarily mean to prove it. There's actually not very much that's provable in the world. You can prove 1 + 1 is 2 and a few things like that. But we can often show that things are incorrect. So that's falsification. So most of the scientific hypotheses that we have, if we know that we can find evidence that proves they're false, then we've managed to falsify that hypothesis. But if we test it by looking for this evidence and we cannot show that it is false, then we basically call it an unfalsified hypothesis. So when you're constructing these hypotheses, you basically look for things that can be proved false, and then you test them that way. So it's not really about proving things correct for the most part. It's the way that science works. You know, we don't deal with too much in the way of facts. We work with hypotheses that we test. Like science is a method. It's not a fact. It's not a set of facts.
Was there ever a disease hypothesis about the extinction?
Like I mean, everything got thrown out there, didn't it? It was like disease. Did mammals eat their eggs? Did the world get too warm, too cold? Everything got put out there, but there wasn't much support for most of those ideas. So, what's interesting more recently is the world was getting a little bit cold towards the KT boundary. Not so much that it would make much of a difference, but we were starting to see evidence that there were some ice caps forming right at the very end of the Cretaceous period. But it's very doubtful that would have done anything to the dinosaurs because they lived with it for like 20 million years or so, and it didn't seem to affect them. So, but you know, it's good to have those ideas out there. Those were hypotheses that were put forward, and people went out looking for information that would either support the hypothesis or would prove it wrong. And our knowledge grew as a result.
I knew it was throwing spaghetti at the wall there for a while. I remember reading just about everything. And I don't know if you ever watched that show, The Walking Dead, about the zombies, but they had that one guy on there that said, some people think this is what took out the dinosaurs. I remember thinking that. I was like, you know, since the giant meteor hypothesis came along, no one's even brought that up again. It's the first time I heard it since I was little.
Yeah, the meteorite hypothesis really it fits the data that we have right now, and it matches the pattern that we see with the fossils. You know,
it really does. It's all there.
That happened all of a sudden,
and they all got kind of mushed into one spot.
Well, but things did survive. I mean, one of my problems with a lot of the way that we show the meteorite impact hypothesis is that it's all fire and brimstone crashing from the skies, and
a T-Rex is always watching it.
Well, T-Rex probably did see some of it because probably T-Rex in Mexico at the time, so they were probably there at ground zero. But I think that a lot of the models that get put forward are too catastrophic. You know, there were some fragile creatures and things that survived the KT boundary impact, and it would have been very severe in North America, presumably. But I don't know. Part of my hunch is just that we are looking too severely. I think those impact models are a little too severe, and that there's something else that's going on afterwards. Like we look at ecosystem collapse and the loss of niches, and that I think is more of a clue. One of the things that I thought was quite interesting is after the KT boundary extinction, or one of the groups that's not affected is turtles. You know, only one turtle goes extinct at the KT boundary, and it's the one that lives on land in the Hell Creek. The big one lives on land. The ones that live in the water are fine. Crocodiles, they're fine. The only crocodile we lose at the KT boundary is a marine crocodile, and it's probably because the marine Midwestern Interior Seaway went away. So it's interesting. I think that one thing that I think is interesting about these freshwater ecosystems is that they are mostly detritus based. They're based on organic material, so plants and animal matter that washes into the rivers. That forms part of the base of their ecosystem, along with photosynthesis. So long as there's a source of this organic material, the land flowing into the rivers, they have something to base their ecosystem on. It may be heavily reduced, but it doesn't really matter what it is because they're eating, you know, anything, detritus stuff. So I think it's quite telling that this detritus-based freshwater ecosystem is not strongly affected by the KT boundary extinction. And that's a sort of avenue for future thinking. That it's been spoken about before, but I feel like there's a lot of things that haven't been looked at for that. I'm curious about, when do turtles go extinct? When do crocodiles go extinct? What conditions make the animals go extinct at the KT boundary? that don't go extinct? What conditions make things like turtles and crocodiles go extinct that are different from the KT boundary? What does that tell us about the KT boundary effects?
You reminded me of something when you said the turtle thing. Sorry, didn't mean to interrupt
That's
you. That's
right.
It's this turtle shell's at the Tennessee Aquarium in Chattanooga, and it was a. Well, you said it's the only one we lost to the KT boundary, not the only turtle to go extinct. I'm politicizing your words there.
I'm not really talking globally. I mean, one of the things is that species evolve over time anyway. So you need to have a very fine time record to be able to assess who's going extinct. So when I say only one species go extinct, I'm talking about North America Valkyrie, which is the only really well-studied Cretaceous Tertiary boundary formation.
I had to look that up. I guess I put words in your mouth. It's like, wait a minute.
No, it's all right. I mean, it's. I'm not saying that people aren't studying the Cretaceous Tertiary boundary elsewhere. I'm just saying that the
yeah. Oh, I got you because I forgot that detail. I was seeing where that was from to see if it was that turtle you were talking about.
No,
how did that affect the Gobi Desert species over there?
I don't know, but it did.
I
mean, it's very easy for us to think a giant meteorite hits Mexico and North America probably had a very bad day, but how does that affect the other side of the world? I mean, once you get ash and various chemicals up into the air and they can circulate around the world, then they can have an effect in many ways. But
the Gobi dinosaurs are like the DC universe of the dinosaurs when ours are the Marvel. You know, you got your Triceratops and your Brontosaurus and your T-Rex and your Parasaurolophus, and over there you got the Microceratops and that weird duckbill looking one.
Well, it's kind of interesting that now we're reaching outside of my expertise, but like the global circulation patterns of things like weather, you know, the northern and southern hemisphere are more separated than say Mongolia and North America, because we're both in the northern hemisphere. And in fact, the dinosaurs in Mongolia and North America are quite closely related, because every now and then they would swap. Some would go up to Alaska and hop over to Mongolia, and others would come over from Mongolia from Asia into North America. So there's quite a lot of interchange of different dinosaur groups between North America and Asia, more so than there is between South America and North America.
Oh, really? So it's like, because they're like on the same plane, then that makes total sense.
Yeah, it's every now and then you can get across from the Bering Straits. You can get across from Asia into North America and track your way down. But South America used to be a little bit more separated from North America. So unless you were very good at island hopping, it was difficult to get there. I think also the climate may make a difference, because if you're a dinosaur in South America and you're coming up to North America, you're crossing across the tropics basically. So maybe that's a boundary as well. But like all these great big sauropods and things in South America are quite different from the North American fauna for the most part.
I know I went through a period in 6th grade where I was obsessed with the Gobi Desert. I even won a trivia bowl competition with it. Gobi Desert knowledge.
It's an interesting place. I went there, and Jack Horner took me and John Scannella, and he took other students the year before, but we went there in 2007, I think, maybe 2008. But we went collecting Psittacosaurus. We found about 30 Psittacosaurus skeletons over about a week, and a few other things as well. It's quite an amazing place. It's quite. One thing I found exciting about Mongolia, it felt very new. You know, like the country is rebuilding itself, and it felt like a real frontier.
Yeah, it goes back. It rebuilds itself every few centuries, it seems.
You know, I think they'd come out of communism relatively recently, and so there was still quite a lot of things being developed at the time. And they've got a lot of mineral resources that are being very well developed right now as well. So their economy is sort of growing. And part of the result of that is that they've been much more protective of their fossils. Boldra Minjin is a Mongolian paleontologist who was at the American Museum and at the Museum of the Rockies when I was there. And she's been pushing really hard to make Mongolia realize the importance of its fossils, especially its dinosaur fossils. And they've been much more, and one of the reasons you don't see them for sale very much anymore is because of her efforts. She contacted the president there and said, we need to look after our fossils. They're amazing. And he really went for it. It's been really great what they've been doing, protecting their resources and educating Mongolians about the cool stuff they have in their country.
I just found her bowler. What's her name? Bowler Minjin.
Boldra Minjin.
Mm-hmm.
It's
okay.
Yeah, it might be written the other way around. I can't.
Yeah, I found her. I was trying to read it out. That's pretty cool. Yeah, that place is like an all-star cast of dinosaurs over there. All the ones we don't have.
Yeah, and sometimes precursors to some of the things that we have in the States.
Mm-hmm.
And that's interesting in itself. It's kind of cool that they swap over. A few species come here, a few species go there, and then they evolve along their own way and start looking different, and then swap back again. Like tyrannosaurs do that, ceratopsians to an extent. These weird crested hadrosaurs, the lambeosaurines, probably came in from Asia and crept into North America. And some of them got really far south, but most of them seem to be limited to the north. Quite a lot of that kind of thing, because I do a lot of work on the different ages of different rock formations and trying to line them up precisely. When we get the rock formations in North America lined up very precisely, we can start seeing the timing of the different dinosaurs and when they have come over from Asia, when they might be splitting and evolving for themselves. It's a big part of what I do.
That's what I always think about when I think of the Gobi Desert is the Protoceratops and those crested, the duck-billed, the hadrosaurs.
Yeah, when I visited there, we were in the early Cretaceous part, so that was where you get Psittacosaurus. We found a stegosaur site, the last stegosaur on Earth, I used to call it. It was we've got a couple of vertebrae which are very distinctive, and they're still there. It's an early Cretaceous stegosaur. There's not many of them around, but someone needs to go and dig a big hole to get it out. Yeah, it's been there since 2008, I guess.
Where'd you say that was?
Mongolia.
Mongolia? Oh, wow.
They have a specimen which was found in China, but I believe the specimen was lost or partly lost. So early Cretaceous stegosaurs are not common.
No.
But they are there in Mongolia if you know what to look for. And the thing about stegosaurs is their vertebrae are very distinctive. Their backbones, their dorsal backbones, the ones in the middle of the back, they're kind of stretched out. They have a really tall middle section around the spinal cord. And when you find one of those, they don't look like anything else. So that's what we found. And there were a couple of ribs and a bit of a limb bone with it. So it's the last stegosaur on Earth, I call it.
So it actually is possible that a stegosaur and a T-Rex did fight.
Probably not a T-Rex, but
is it close? Maybe a theropod.
Are there any tyrannosaurs there? It's the early Cretaceous. I mean, they're probably worse than tyrannosauroids, but not tyrannosaurids.
Because that was always a thing growing up, is they'd always show a stegosaurus stabbing a T-Rex, and I'm thinking that's not even possible.
Yeah, they used to just mix and match those things and not worry too much about how accurate it was.
I've got an uncle that won't speak to me about how I smarted off about his wrongness one time back in like 94. I'm like, what? I don't know. I was like, no, it's a Triassic dinosaur. It's clearly Cretaceous. How dare you, Tom?
We get kids coming into our museum who separate all the toys based on the ages they're from.
That's freaking me, man. I'm that kid. I've probably been there. There's no reason this Dimetrodon should be next to this T-Rex. Get it over here. What else? What else? You got anything else, Wild Trees?
Let me see. Well, yeah, what you were going to mention about your before we went on air, I was asking you about your dissertation work, and you were going to start talking about the work you did with morphology. I wonder if you could tell us about that.
Oh, well, my dissertation is largely concerned with how a better understanding of time, or the fine slices of time, can tell us basically how dinosaurs evolved better. And then I have a sort of something I've done quite a bit of work on is some functional morphology, particularly of claws, and basically the different functions that some dinosaurs had for their claws. We were working on foot claws. So we did work on raptor dinosaurs, things like Velociraptor and Dromaeosaurus, and looking at how they used the big claw on the foot. We made comparisons with modern birds of prey. We also looked at the foot claws of the big sauropod long-necked dinosaurs. And when people draw these, or at least in the past when they drew them, they often drew these like Diplodocus and Brontosaurus. They drew them with feet like elephants, but they actually don't have feet like elephants at all. They have these weird banana-like curved, I know all claws are curved, but these ones are kind of curved sideways. And when they flex the toes, the claws kind of rotate down. And so we were very interested in what that was for. And we'd surveyed, one of the ways that I do this functional morphology, we look for modern animals that have very similar looking structures, and we see what they do with them. So I saw some desert tortoise feet, and they have very similar weird shaped claws on their feet. And what's cool is what happens is, like sauropods, when they're usually walking around, they keep the toes kind of slightly curved so that the claws stick out sideways. And when we see trackways, we can see the claws to the side when they're walking around. So fossil trackways, we see the claws on the side. But when they flex the feet, the claws kind of rotate round and they make like a wall. They're kind of like an inclined wall on the front of the foot, like a hoe shape. So the desert tortoise has the same sort of thing, and it basically makes the shape with the foot so it can dig its burrows. Desert tortoises are burrowing tortoises. They're the only true tortoises in North America right now.
I know that box turtles have feet like that. Now that you're mentioning it,
well, it's seen in a few. It's seen in a few turtles, and so one of the things that's interesting,
sideways flat,
is specifically these claws are used for a lot of things, but we think that it's for digging. So this is a digging adaptation in sauropods, which basically leads you to the question: were sauropods burrowing animals? We had a little illustration done of sauropods living in burrows, and of course that's kind of absurd because they got so big. But one thing that sauropods did need to do is lay eggs and make nests. And they were so large, and their eggs were so small compared to them, they really weren't looking after their nests much, I don't think. So we're suggesting that the claws on the feet of sauropods were there and evolved these specific shapes basically only for digging nests. Dig a big hole, dump your eggs in them, and then bury them again. And so that's some of the sort of functional morphology work that we did with sauropod claws. And then we also looked at the size and the curvature of claws in raptors, both in modern birds of prey and then things like dromaeosaurs, troodontids, and other carnivorous dinosaurs. And we were the first people to look at the difference in size and curvature between toes. Often people had just looked at one toe of the foot, but that doesn't tell you very much. What's interesting about dromaeosaurs, raptors, birds, is that the different toes kind of have different functions. The middle toe, 3, and I know I'm holding up my hand, but my feet wouldn't work for this. The middle toe 3 is mainly supporting the body weight. So it's actually quite boring, and that's the one that most people had looked at in the past. But you know your raptors, digit 2, the inside, that's got that great big claw on it. And digit 4 is a smaller claw. And they're all different curvatures as well. And so, in general, 3 is for walking on, 4 is a stability thing. It sticks out sideways. If you're going to fall over sideways, your little 4-digit toe, digit 4 can stabilize you. 2 sits in the midline under the animal. So if it's going to put its weight on something, it goes on digit 2. If it's going to stick its head down and bite something, its digit 2s are closest to it. So we were looking at, someone had told me many years ago that certain birds of prey had a big claw on their digit 2, their inside toe, just like Velociraptor did. And I looked at a few in museums and I didn't see it. But then when I was a grad student at Museum of the Rockies, John Scanella, who's the curator now, he came in from collections. He said, I've got this box of bird of prey feet someone put here. And I thought, oh, this is quite cool. I'll have a look at those. And some of them did have a big claw on their digit 2 and others didn't. So we were asking, like, why is this the case? And the big claw on the 2 is, the really big one is seen in hawks and eagles. Falcons don't really. They have a claw on 2 that's bigger than 3, but they don't have a really enlarged one. So by looking at lots of videos on YouTube, and YouTube was quite new at the time, and seeing birds of prey and how they use their feet with their prey, we were able to show that this big claw on birds of prey locks into whatever it is they caught. It's not for slashing. It's not for impaling them to death. It basically locks in and holds onto them. And so we suggested the same thing. It was the reason why Velociraptor had a big claw on its digit 2. It's for locking into something it's just caught, so it can stand on top of it and pin it down, and then basically eat it alive, because that's what modern hawks do. Falcons are a bit different. They asphyxiate their prey. Well, this is a much more complicated answer. There's different ways that birds of prey kill, and it depends on the size of the prey as well. But falcons can snap the neck of their prey, so they have like a quick kill method. It's very difficult to kill your prey if your prey is large. So the big claw is generally used for locking into big prey. So that's where we think that Velociraptor was a large prey specialist, or at least it was adapted to be able to take larger prey on average. Now, I don't mean they were huge. I just mean, but for me, a small prey animal fits into your hand or fits into the foot of the raptor. And then large prey is too big to be held within the foot. And then really large prey is too big to be pinned down. It's all relative to the size of the raptor. But for me, like, a large prey item is like a sparrowhawk catching a pigeon. You know, it's not a sparrowhawk catching a dog, something like that. We published on a lot of this in. Is the question?
Yeah, Mindy had one.
Oh, so the initial foot morphology in birds. So, do you know the first foot morphology was in birds? Anisodactyl, zygodactyl, heterodactyl. Was there one initially and others evolved from it, or did different types develop independently? Well, that's a very good question. So the question is asking, basically, we have different terms for the different orientation of the toes. So in modern birds, we have this anisodactyl condition where the 3 front toes face forward and 1 toe faces backwards. Zygodactyly is when you have 2 toes facing forwards and 2 toes facing backwards. That sounds a bit weird, but you see it in all parrots, for example, and you see it in ospreys and owls. Ospreys and owls actually have a digit 4 that they can rotate. So they can have 2 toes facing forwards, 2 facing backwards, or they can rotate the digit 4 to have 3 facing forward and 1 facing backwards. Interestingly enough, cuckoos, they have a zygodactyl foot as well. So the different orientation of the toes in all these different modern birds tends to be related to what they're doing with their feet. Now, the interesting question with primitive birds and with these little raptor dinosaurs isn't so much the 3 toes that face forwards, because based on footprints, based on the bones, we're pretty sure those 3 toes face forwards. They're called 2, 3, and 4. But the 1 which faces backwards in modern birds, that one is a bit more of an open question. Originally, it would have been at the side. I'm using the mirror on my camera. It would have been at the side like this in very primitive archosaurs, the ancestors of dinosaurs. And then certainly in birds, it's rotated around like this. So for most theropod dinosaurs, was it backwards facing? Was it forwards facing? Was it coming in from the side?
Mm-hmm.
That's been an open question. And there are specimens, some specimens of velociraptor feet, for example, and some Deinonychus feet that we've looked at that suggest that that one is coming in from the side, which gives a slightly different grasping foot. Like we suggest that Deinonychus velociraptor had feet that could grasp their prey, but it's not. The opposing digits are sort of the fourth digit and the first digit. So now it's difficult for me to see on this screen, so I don't know how you're all doing it. Looks more like this. There we go.
Mm-hmm.
Rather than this, which is like a modern bird. I wish my fingers moved better. It's more like this. So
it's very eagle-y.
The eagle has a fully reversed digit 1, so it can oppose digit 2 and digit 3. Whereas Deinonychus and Velociraptor, it kind of came in from the side. It wouldn't have been quite as effective as it was in eagles and hawks today. But that's because eagles and hawks are fantastic animals that have had an extra 60 million years to evolve.
Yep, they got to jump on them.
And they only have to do one thing. They're not very good at walking and running, you know, when you see eagles and hawks.
We came down the road the other day, and there was an eagle by my parents' house on the side of the road hanging out because it was raining, kind of. It was just sitting there, and it hopped across the road. I said, if we'd have hit that damn eagle, it would have been the rest of the day. So thank God. That would have ruined our weekend. They were just standing there, big as a kid.
They're amazing to see. We see lots of goldens and or boldies out where we do our field work. There were some goldens that were nesting there one year, and they'd buzz us every day to see if we were dead yet. But they were just young ones, but yeah.
Goldens are incredible because you don't see them. You don't like when you're looking for eagles, you look for the bald eagles. You see that golden one and you realize what it is. I think they're almost prettier than the bald eagle because it's like this engineered hulking bird that could kill you if it punch.
It's pretty interesting when you see how the big eagles do kill big prey. Sometimes they do. It's very rare, but they do punch sometimes. They dive, they stoop their prey, and they smack it with a fist. And sometimes they'll have a leading claw out, depending on what they're attacking. But it's more common. I did miss that question. I didn't read it.
Sorry. Oh, she said thank you.
Oh.
She said
yeah, sometimes what we call the very large prey strategy is called prey riding, where eagles will do this to sheep and goats, where they basically just land on the animal's back and they embed their claws and then they just ride it. And as the animal's trying to get it off their back, they tear open the wounds a bit more and the thing just sort of bleeds to death eventually. And that's basically a way that things like Velociraptor could have taken on very large prey just by locking with those claws.
It's got to be a similar SOP since they're close to the same animal.
I mean, they're closely related. I mean, they're differently derived, but what we would argue is they have the same body plan. And so if you're an animal with 2 legs and they've got primitive wings, you're going to be evolving the same sorts of structures because you've got the same stuff to deal with. It's not like a jellyfish and a bird. They're going to solve problems in different ways. A bird and a dinosaur are so similar in their anatomy.
What's that called? Wild trees, the fitness. It's the fitness of the animal.
Yeah, fitness is a number of children that you have that are healthy enough to produce children as well. Yeah.
Truth. That's cool. I was going to say we have a catfish pond in our family, and we had to install eagle deterrents because they're eating all the damn fish. And we were worried to death that my grandpa was going to shoot them because they're eating this fish. I'm like, you can't shoot the white-headed crows. Don't do it. It's not worth it. You don't want to spend the rest of your life in the stony lonesome.
That's the symbol of this country, right? It's patriotic. They're fabulous animals. They really are.
A farmer's animals. He was getting pissed off. It was funny. It was like a running joke for a while. But we had to put decoys out there, and we had to get balloons from the grocery store that were metal, the Mylar looking balloons, just to shine like something was out there, because it was getting bad. Those eagles were just swooping in like a seafood buffet.
I guess it was.
Imagine if you had 10-pound catfish at the ready. Know how to hunt. All right, we'll start to wrap up. I got one more question, and it's one of my immature ones. But what the hell happened to the iguanodon? How come it went from this Allosaurus looking thing to a duck-billed dinosaur? When I was little, it was a predator. Now it's a hadrosaur.
I don't think iguanodon was ever considered to be a predator. I mean,
just remember when I was
even when it was only known from teeth. I mean, iguanodon was named iguanodon because its teeth looked like that of a plant-eating iguana.
I remember the song we sang about it, saying it was very mean.
It could have been mean. I didn't, just because it eats plants doesn't mean it's mean. I grew up in a place with a lot of dairy cows, and people think they're docile. It's like, no, you don't want to get in the field with a bunch of angry cows.
Just get a vegan pissed off. They're pretty mean.
I mean, people get trampled. An iguanodon would have been the same. Like, it's not harmless. Its sheer size makes it a danger. That's why people get trampled by bison every year in the national park.
No, that's just dumb.
It's not friendly. It's just not. It's not going to hurt you that much if it bites you. To be fair, but there's plenty of other ways to hurt you.
What's the meme? Why not friend if friend shaped? don't pet the bobcats. But your friend shaped. Why not friend if not friend shaped?
Iguanodon's very close to my heart because I grew up in England, of course, and I collected a bunch of iguanodon bones. So it's one of the dinosaurs that really influenced me. I think its thumb spike is really cool. It's like, why does it have a thumb spike? And then hadrosaurs, the more derived ornithopods, don't have a thumb at all. So the thumb spike, whatever it did, wasn't needed in hadrosaurs. So that's kind of interesting.
Is there a chance that that's not how they're supposed to look, or is there just so much evidence that's what?
No, they have articulated arms with the spikes in place, so they know what they look like. Yeah.
Okay, I'm just making sure they didn't find one iguanodon with a thumb laying next to it, and that was what they went with. Like the Gigantopithecus, they found one jawbone, all of a sudden it's Bigfoot. I didn't want. But I assume if they put a lot of confidence in one of those having a thumb spike, they must know more than I do.
Oh yeah, they found like 30 skeletons in Belgium in like the 1880s, I think, and some of them had like a complete hand, so they can see what it is. That's why that's how they found out that it wasn't on the nose. They originally reconstructed the spike being on the nose, but it's not.
I remember that song from kindergarten. It was very mean, but oh, not so dumb. Iguanodon. Never forget it. I even talked to the guy. I even had the same conversation with the guy at the Rockies. It's like, what happened? How come? Like, did their PR improve? I swear to you, we colored a picture of a theropod. That's the two-legged one, isn't it? The predators, theropods.
Yeah, but there are two-legged herbivores as well.
Yeah.
And there are theropods that ate plants as well. So it's all a bit. Yeah, most theropods we think of as carnivorous, but there are groups.
Yeah. But like, I swear we colored a picture of a like an allosaur that had a thumb spike, and that was the iguanodon. But this was like 1988, so God knows.
Maybe it wasn't so well drawn.
Yeah, I mean that, and I was 5, so I could have just got it wrong. Well, all right. I appreciate you joining us tonight. Wild Trees, you got anything else? Because this was incredible, and I want to. He's on Mountain Time, so God knows what time it actually is.
No, that's it. I'd love to have you on my channel too at some time. We'll, if that's okay with you, I'll send you a message. That'd be great.
Yeah, sure. It's been great fun. I like things where I don't have to give too much of a presentation.
Oh no,
sit and chat, right?
You didn't even have to talk about dinosaurs tonight. We just baited you into that. You could have talked about your Lord and Savior Jack Horner just the whole time, and about your Stetson hat choice. I mean, I won't care. I had a Bigfoot guy on here last night, and we talked about fish the whole time. I don't even know what happened. I blacked out.
My hat choice, I like the white. It is important to me. I always buy the same hat and have them for like 10 years. It's
what
just
brand
white
is it?
Straw. And
is it a Resistol?
Justin makes the hats I like.
Oh,
they're the ones
Justin
I get.
hat.
Yeah.
Okay.
Because people say, "Oh, the straw ones blow away." It's like, well, you learn how to tip your head into the wind, don't you? It's like they reflect the sun. They keep you nice and cool. Like, I swear by a proper cowboy hat in the field.
See, that's the most British thing I've ever heard. I swear by a proper cowboy hat.
Hey, I took my cowboy hat to Mongolia and China. I was wearing it out there. It's like top of my head doesn't have much cover anymore, so I need something. Though my brain will fry. And I love my cowboy hats. I always have a spare with me. I have one from last year and then the new one. And as they get more mangled, as people shove them into the truck, I switch over. But yeah,
Totally
absolutely.
makes sense. I know the feeling about the back of the head. My neck's not red just from my heritage. It's because I'm pasty. I burn like a little baked potato out there. I couldn't imagine being out there in that sun like that at that angle, just on your belly.
Well, we have shade tarps and things. That's another bit of the science, is like putting up shade tarps. You get twice as much work done, and people are much more comfortable. So there's all sorts of little things that.
Yeah.
Ways
imagine that's a whole morale. That's a morale boost right there, not having it beaten down on you.
Oh yeah, absolutely. The sun moves though. Can you believe that? You put the tarp up in the morning, and then in the afternoon it's somewhere else. The sun. It's a pain.
You're telling me the sun moves? I thought we were on I thought we were on a firmment.
Oh, that's true. Well, the Earth moves. Well, the sun moves as well.
We're gonna do 3 more hours now. Way to go! gonna light one up. Okay. So all of a sudden we're on Rogan. All right, y'all. We'll end the live broadcast. Thanks for being on, Denver, and I'm going to find a way to have a panel to bring you back on. Thanks everyone for watching. Thanks Mindy for the scientific questions, and be sure to subscribe, please, and check the links for Fowler Paleo. I'm not sure what kind of services you offer, but the pictures are awesome, so it's worth the trip, worth the click. Thanks everybody.